Hello. Let's do some notes. This is in your notes packet, page 10 that I printed off for you guys, section 4.3. And hey, it's handy. There's snow, or there was snow. Maybe there'll be snow again. There's snow on Janet's driveway when the snow begins to fall at midnight. Okay, so we're gonna have to keep that in mind, right? And this is literally from an old exam, okay, an AP exam. So from midnight to 9 a.m., the snow accumulates on the driveway at the rate modeled by this cubic feet per hour, where T is measured in hours since midnight. Janet starts removing snow at 6 a.m. The rate in cubic feet per hour in which Janet removes snow from the driveway, T hours after midnight, is modeled by this. So the snow is falling at this rate. It's accumulating, right? There's the ground and the snow is building up on the ground at this rate. And um, it's being removed at this rate. Okay. So what does this tell us here? This is reminding us that it was started snowing at midnight, and at time zero was midnight, and at 6 a.m. was when she finally started moving it, right? Because she was sleeping. So there was no movement. There was no removal from 0 to 6. Okay. All right. Now it says find the rate of change of the volume of the snow on the driveway at 8 a.m. Now I want you to remember this says it's already a rate of change, right? This was a rate of the snow growing on the ground. Think of it growing, increasing on the ground. And this is the rate of the snow going away, right? So it's being added by this one and subtracted by this one. So the volume of the snow, it's got to be something where we compare those two, right? If we're figuring out how much snow is there at any point and how is that changing, we have to compare how much is being added to it and how much is being taken away. So let's think of it this way. Let's give it some name. I don't know. No, but it's the rate of the change of volume. So I am going to go ahead and call it an R. Does that make sense? Or how fast it's being added and how fast it's being taken away. That tells us how fast the volume is changing. Are we okay with that? But they specifically want to know, they're asking about what's the rate when that time is at 8 a.m. And what if it starts at midnight, how many hours later is that at 8 a.m.? Is that okay so far? Okay. Now, since this has E and cosine, I'm going to go ahead and assume we're allowed to use our calculator for this. It doesn't tell me anywhere on here if I'm allowed to or not. But what I want us to think about real quick is when time is 8, F is real easy, right? We just plug that into that equation there. The minus now G of 8, right? There's 3 parts. G is a piecewise function, so we got to look at which part we need it in. Which one of these are we going to use, and how do you know? So we're just going to do minus 108. Handy dandy calculator. So we're going to do next. So I got to type that guy in. Ooh, made that too big. That's okay. So I got to type that guy in. Let's do it. 7 times 8 times e to the cosine of 8 minus 108. And then I got to make sure I'm in the right mode. What mode should I be in for calculus class? And what per what? We always have to use the right units. They're kind of picky about this. What per what? What did they tell this was? Cubic feet per hour. So I'm just going to write that. Ta-da! There we go. That's it for that one. It says part A, like there might be a part B, but that's it. All right, let's look at the next one. Penguin population. Oh, penguins are so cute. Look at them. Remember the movie Happy Feet? When my 16-year-old, he's almost 17. My 16-year-old was born, we went, or not born, when he was little, we went to Happy Feet and he sat there and he came out, he was just dancing. He was like 2, couldn't talk really much, but he came out of that movie just dancing his little feet like Happy Feet. Every time I think of penguins now, I think of him and Happy Feet. All right, so penguin population on an island is modeled by a differentiable function where P of t represents the number of penguins. Ah, so this is not a rate. This is the number of penguins, okay? And t is measured in years for between 0 and 40 years. There's 100,000 penguins on the island at time t. The birth rate for the penguins on the island is modeled. Okay, so we're getting some penguins added at this rate, right? And the death rate is modeled by this. So we're getting some penguins subtracted here. What's the rate of change in the penguin population on the island at t equals 0? All right, so what am I going to do here? What am I looking for? What equation are we going to start with here? Let's call it R again. You could call it P for penguins if you wanted to, but I want to remember that it's a rate of change. That'll help me remember this is already a derivative. I don't have to take the derivative unless they say something about what's the rate of the rate of change, and that's a different story. Okay, so this is a rate, and we're going to do B. You hear my son in the background. He's playing a video game with a friend. It's kind of creepy. All right. So I'm just going to type this in the calculator, which equals 750. What are the units? It's not just penguins, right? It's not just penguins. This is penguins per year, not just penguins. It says penguins per year because this is a rate of change. Penguins per year. Side note, does that mean they're increasing or decreasing? Yeah, I mean, if this is true for the first 40 years, then they're increasing 750 penguins a year. That's right. Next. This is from an AP exam. When a certain grocery store opened, when it opens, it has 50 pounds of bananas on. Oh, I like bananas. Customers remove bananas from the display table at a rate. So they are removing them at a rate of blah, blah, blah from 0 to 12, where F of t is measured in pounds per hour and t is the number of hours after the store opened. After the store has been open for 3 hours, store employees are putting some back. So they're adding them back in. But that starts at time 3 and goes up to time 12. Oh. So they're always being removed from 0 to 12, but they're being added back in from 3 to 12, where G is measured in pounds per hour and T is the number of hours after the store opened. Find F prime of 7, and then using the correct units, explain the meaning. Okay, so F prime of 7. Okay, so now we have to remember this is F prime of a rate. This is a rate of a rate. A rate of a rate. Okay, a derivative of a rate, and a rate is a derivative. So we're saying a derivative of a derivative. So we need to think of this carefully. Okay, so the rate at which what's happening, the customers are removing bananas from the table is now, is it going up or down? Is this rate going up or down? Is this the derivative going up or down? What's negative? So it's decreasing. Is decreasing, slowing down at a rate of, now we go ahead and put the number in, but we already used the word decreasing, so we don't have to put this negative. Okay, we already used the word decrease, so we don't have to write the negative. 8.120 pounds per hour per hour. Why do I have to put that in there again? Because we're doing the rate of a rate, okay? Rate of a rate, pounds per hour. So we're basically saying the accelerate, we're talking about the acceleration here. We're saying it's slowing down. They're still removing them, but at first they were apparently removing them like this, and now they're removing them like this, maybe, right? It's slowing down. It's still happening, but it's slowing down. All right. Now let's look at this next part here. So it says, is the number of pounds, so not the rate, but the number of pounds on the display increasing or decreasing at time t equals 5. So they're not saying find the derivative of the rate. They're just saying find the rate of change. What's happening? How many bananas are coming and going? How is it changing? What's the speed of it? Is what they're asking. At time equals 5. Now, for some reason, I put 7. At time equals 5. Okay, so, and then it says, give a reason for your answer. So, like, why do you think this is happening? Not show me your work. Give a reason. Give a context. What's going on with the bananas? Okay. So let's see what we got going on in here. So we're using a calculator again, and I got to do how many are there minus how many are being removed. How many are added minus how many are being removed. So we plug that in to our handy dandy calculator. I did G of 5 and F of 5, and then I subtracted the two, and we get negative 2.63, and then we got to talk about, sorry, 2.263, my bad. Then we got to talk about what the heck does that mean. Um, so more people are removing bananas. Well, maybe not more people, more bananas are being removed. More bananas are being purchased than replaced. Make sense? Okay. So those are our notes that we just did. And now I want you to actually do this activity, and I want you to show all your work and write out all the words. And if all of your words are exactly the same as someone else's, all of their words, then I feel like you either work together and you should put their name on your paper too. Say, hey, I worked with so and so, or you're cheating off something. So quit cheating, right? So try it, do your best.